Hey guys, welcome back to my channel. Today we're going to do the second variant for paper 2, Standard Maths. This is from the May June 2025 series. In this paper, we will discuss the detailed solution of this paper and see whether this was difficult or easy overall. For some who still haven't seen the other variants, you can check out the link above. In this playlist, you will find all of the past books on Cambridge Maths IGCSE 05, both extended and full. So let's start with this one. The first question says that shade one more small square so that the diagram has one line of symmetry. So for that, what you can do is you can shade this one, because this way you will have this line of symmetry. Or you can shade this one over here. This way you will have, again, one line of symmetry. So these are the two squares you can shade. Then it says shade one more small square so that the diagram has a rotational symmetry of order 2. So to have a rotational symmetry of order 2, we will shade this square over here. Why? Because if we turn this square 90 degrees clockwise, we will have these two over here, and then these two over here. And then we'll again rotate it. So the next one will be these two over here and these two over here. After two rotations, we have the shape exactly as it was originally. So we shade this square. When the scale drawing shows the position of two villages P and Q, the scale is 1 centimeter represents 0.5 kilometers. Find the actual distance between the village P and Q. So for this, you will use your ruler, measure the distance between P and Q, and whatever you get, you will multiply it by 0.5 to get the actual distance. Actual distance will be in kilometers, and the one on the map will be in centimeters. Then measure the bearing of village Q from village P. So to measure the bearing of village Q from village P, this is the angle that we need to find. Whatever the bearing is from, you measure the angle at that point. You'll start measuring the angle from the north of that point and go in clockwise direction. So in this direction. And you measure the angle till the line which connects both the points. So from the north to the line that connects P and Q. For this, you will need your protractor. You will put it over here at P and measure the angle. So that will give you the bearing. As you can see, the angle is more than 90 degrees, so it's going to be somewhere between 100 to 112. I can't measure it right now because I'm doing this online, but when you solve this, just use the protractor correctly and measure this angle. Then question 3 says the diagram shows two straight lines intersecting two parallel lines. Find the value of x and y. So for this, you need to remember your properties of angles in parallel lines. In parallel lines, we have alternate angles, we have corresponding angles, we have co-interior angles, and then we have vertically opposite angles. This angle is equal to this angle because they are corresponding angles. This angle is equal to this angle because, again, they are corresponding angles. So as you can see, this is a straight line. And sum of angles on a straight line is equal to 180 degrees, which means 180 equals to 45 plus x plus 65, which means x is going to be 180 minus 110. So x is 70 degrees. And then to find y, we can see that this is another straight line. So 45 plus 70 plus y equals to 180, which means y is going to be 180 minus 115, which is equal to 65 degrees. So x is 70 and y is 65. And it says Samira picks one of these cards at random and replaces it. Find the probability that she picks an odd number. So odd numbers are 1, 3, 5, and 7. So there are 4 odd numbers. So 4 out of 7 is the probability of picking an odd number. And since she's replacing it back, that means the total number of cards will not change. Then Samira repeats this 35 times, calculate the number of times Samira is expected to pick an odd number. So to find the expected number, you always multiply the probability by the number of times an event is happening. So 4 over 7 times 35. 7 ones are 7. 7 fives are 35s. So 4 times 35 is 20. That is the number of times she's expected to pick an odd number. Then it says translate triangle T by the vector 0, -2. So as I've told you before, the value above is the x value and the value below is the y value. So the x value shows the horizontal translation, whether the shape is moving to the left or right. And the y value shows the vertical translation, whether the shape is moving up or down. Since x value is 0, that means there is no horizontal movement. However, the y value is -2. That means the shape will move 2 units down. So since it's going to move 2 units down, this point will come over here, this point will come over here, and this will come over here. So this is your translated image of triangle T. Then describe fully the single transformation that maps T onto U. Now triangle T onto U is going to be rotation. As you can see, direction of the shape has changed. Size is the same, so it's not an enlargement. And it's not translation because in translation, the direction doesn't change. So we have to figure out what is the rotation, by how many degrees are you rotating, what is the direction of the rotation, what is the center of the rotation. Based on this, the direction of the rotation is 90-degree anti-clockwise because we're going from T to U, so it's in this direction. When we rotate it 90 degrees anti-clockwise, the direction of the shape is going to be this. So we know one thing, it's 90 degrees anti-clockwise. We have the degrees, we have the direction. Now to figure out the center of rotation. For the center of rotation, it's going to be in the first quadrant because it can't be over here, here, or here. So let's say over here we pick 0.23. What you need to do is you need to check the horizontal and vertical distance of a point on the shape from the point that you've selected as the center of rotation. So for this, your horizontal distance is 3, vertical is 0. Now for the same point on U, the vertical distance is 4 and the horizontal is 1, which means this is not the center of rotation because for the center of rotation, the distance from the center, the horizontal and vertical distance, will be the opposite for the image. So for example, if over here 3 is the horizontal distance, for the image, the vertical distance would be 3. We swap the values. So since it's not swapping, so this is not the center. Let's pick 2, 2. So for 2, 2, horizontal distance is 3, vertical is 1. Vertical is 3, horizontal is 1. Now this one works because our distances are swapping. Horizontal distance is 3, vertical distance is 1. This is for the original. Now for the image, horizontal distance is 1 and vertical distance is 3. As you can see, the values are swapped, which means the center of rotation is going to be 2, 2. Whereas if it's a 180-degree rotation, your horizontal and vertical distance will remain the same of the point from the center of rotation, whether it's the original or the image. So we'll write 90 degrees anti-clockwise rotation about the center 2, 2. Then it says solve 8x plus 7 equals 39. This is solving a multi-step equation for algebra. So first we move 7 to the other side. So 8x equals to 39 minus 7, which is 32. Then x equals to 32 divided by 8, and that is 4. Then we expand the bracket. So 10y minus 2 equals to 24. When you're expanding the brackets, the term outside the bracket gets multiplied with all of the terms inside the bracket. Now we take 2 to the other side. So 24 plus 2, 10y equals to 26. Y equals to 26 divided by 10, which is 2.6. So that's your answer. Then it says these are the first 4 terms of a sequence. Find the next term of the sequence. So if you notice, to go from 11 to 8, we need to subtract 3. Then to go from 8 to 5, again subtract 3. And from 5 to again subtract 3. So we're subtracting 3 from each consecutive term. So for the next term, we subtract 3. 2 minus 3, and that's going to be -1. For the nth term, what we do is we find the common difference first. Common difference over here is -3. We're subtracting 3. So whatever is the common difference, you times that by n. So -3 times n. And let's see if this is the nth term or not. So first term based on this would be -3 times 1, which is -3. Now obviously, first term is 11 over here, not -3. How can we turn the -3 into 11? We can do that by adding 14 to it. So now, if we use -3n plus 14, the second term would be -3 times 2 plus 14, and that is 8. Third term would be -3 times 3 plus 14, and that's 7. So which means -3n plus 14 is our nth term. Remember, whatever is the common difference, you will multiply that by n. If you're subtracting something, then it would be negative that number times n. If you're adding something, then it will be positive. You begin with using that as the nth term, as we did for -3n. Check if it gives the same values as the sequence. If it doesn't, then you have to add or subtract something to the -3n to see what would give us the exact same terms as given in the sequence. And find the highest common factor of 36 and 54. So let's split the 36 into its factors. 36 is 9 times 4. 9 is 3 times 3, and 4 is 2 times 2. We cannot further break 3 and 2 down because they're prime numbers. So these are our prime factors for 36. Now let's make the same factor tree for 54. 54 is 9 times 6. 9 is again 3 times 3, and 6 is 3 times 2. We can see that the common numbers are 3, another 3, a 2, and that's it. So HCF is 3 times 3 times 2. You write the common numbers once, not twice. So there are 2, 3 common, so we just write once. Then there's another 3 common, so we write it once. And then we have 2's common, so we write them once. So that's 9 times 2, and that's 18. 18 is your highest common factor for 36 and 54. Then A is the point 3, -1. Vector AB is 2, -4. Vector AC is equal to twice of AB. We have to find the coordinates of point C. So AC is twice of AB. So 2 times 2, -4, which is 4, -8. That's AC. So if you notice, they've given us the coordinates of point A. Point A is basically the vector position of point A from the origin. So vector OA, the position vector of A is going to be 3, -1. Now AC is basically AO plus OC. We're going from A to O, then from O to C. That's the route that we're following. So if you know that AC is 4, -8, AO is the opposite of OA. So when you change the direction of the vector, what happens is the values become opposite. By opposite, I mean their sign changes. So if something is positive, it becomes negative and vice versa. So 3 will be now -3 and -1 will be 1 plus OC. So now we move -3, 1 to the other side. So 4, -8 minus -3, 1. 4 minus -3 is 7. -8 minus 1 is -9. So coordinates of the point C are going to be 7 and -9. If it's a position vector, that's basically the coordinates of the point. So OC is coordinates of point C, 7, -9. Then it says the length of AB is k√5. Find the value of k. So we know AB is 2, -4. So for the magnitude of a vector, we square the x value and the y value, add them up, and then square root it. So it's basically similar to Pythagoras. 2 square plus -4 square. The formula is the same when we're trying to find the hypotenuse in a right angle triangle. We add the squares of x and y value and then square root. So that's going to be 4 plus 16, which is √20. Now they said that the length of AB is k√5. So this is basically k√5. So 20 is basically 4 times 5, and 4 is a square number, which is 2 times 2. So we can rewrite this as 2√5, which makes k2. The reason why it's 2√5, because if we take the square root of 4, it's 2. So the 2 comes outside of the root and 5 remains inside. So square root of 20 becomes 2√5. P is a point on AB. AP is to PB equals to 1:3. Find the position vector of P. So the position vector of P, AB was given as 2, -4. P lies on AB. So if I draw a line AB based on the given information, A, P, P is somewhere over here. AP is 1, PB is 3, which means total there are 4 parts. So AP would be 1/4 of AB and PB would be 3/4 of AB. We have to find the position vector of P. So let's first find AP. AP is going to be 1/4 of 2, -4, which is 1/2 and -1. So as we said previously, AP would be A to O and then O to P. So if we have AP, which is 1/2 and -1, we have AO, which was given in the question as 3, -1. So now, since the direction is opposite, it's going to be -3 and 1. And we have to find OP. So 1/2, -1 minus -3, 1 equals to OP. 1/2 plus 3 is going to be 7/2. And -1 minus 1 is going to be -2. So the coordinates of OP are 7/2, -2, or you can even write it as 3.5 and -2. This is the position vector of OP. We can't use PB over here because we don't have the position vector of B. We only have the position vector for A. So it's ideal that you go for this instead of wasting time on PB. Then it says the diagram shows a sector of a circle, center O. The length of the arc is n pi centimeters. Find the value of n. So for this, we use the formula for the arc length, which is angle over 360 times 2 pi r. R is 18 and the angle is 45. So the length of the arc is n pi. 45 or 360. So let's simplify this. So we have 45 times 2 times 18 times pi divided by 360. Let's simplify this. Now 45 and 360 come to 9 times table. This becomes 5. This becomes 40. 5, 1, and this is 8. 2 ones are 2, and that's 4. And this becomes 2, this becomes 9. So we have n pi equals to 9 over 2 pi, which means n is equal to 9 over 2. For these type of questions, you need to know how to simplify fractions. And to simplify fractions, you need to know your times table very well. Right, 0.00708 in standard form, that's going to be 7.08 times 10 to the power of -3. You'll move the decimal 3 places to the right. The reason why we're moving it 3 places to the right is because in standard form, the number before the decimal needs to be a non-zero digit. So as we know over here, it's 0. So we have to move the decimal, and the first non-zero digit is 7. So 7.08. And for the power of 10, we use the number of places the decimal has moved. So the decimal moved 3 places. So that's why it's 3. And for the negative sign, since we're moving the decimal to the right-hand side, it's negative. If you're moving the decimal to the left-hand side, it would be positive. Then work out 3.8 times 10 to the power of 22 plus 3.8 times 10 to the power of 23. Okay, so in this case, if you notice, our equation is this. And in this equation, we have 3.8 common, and then we have 10 to the power of 32 common as well. So if you take them outside, since they're common, what we're left with is 1 plus 10 over here. 3.8 comes outside, and when 10 to the power of 22 comes outside, 10 to the power of 23 becomes 10, because we've taken the 10 to the power of 22 outside. So now it's 3.8 times 10 to the power of 22 times 11. And next, what we need to do is we need to multiply 3.8 with 11. So 11 times 3.8, 8 ones are 8, 8 ones are 8, placeholder, 3 ones are 3, 3 ones are 3, add the result, 8, 11, 4. The decimal comes as it is over here. So 41.8 times 10 to the power of 22. Like I said before, the number before the decimal has to be a non-zero digit, yes, but it has to be after the first number. It can't be after the second number. So you move the decimal 1 place to the left, 4.18, and that adds a number to the power, so it becomes 23. Since you moved it to the left, so you're adding 1 to the power. So the 22 turns into 23, and it becomes 4.18. You have to make sure that there's only one number before the decimal in standard form. It can't be more than 1. Then P, Q, and R lie on a circle. QR is the diameter. Find angle PRQ. PRQ is this one. So if this is the diameter and there's like an angle coming out of the diameter, that means this is 90 degrees. This is one of the circle theorems. For these type of questions, you need to revise the circle theorems. You need to know them by heart. The moment you see a circle, you should be able to identify which circle theorem is used. You need to know them that well. If you don't know your circle theorems, I'm attaching a link above. In this short, I've talked about all of the circle theorems, so you can just go through them and make a note about like which circle theorems you know and which you don't, and then you can practice more on that. So 90 degree over here, so we can easily subtract these two angles from 180 to get the third angle, because the sum of angles in a triangle is 180. So for the first reason, we'll write angle RPQ equals to 90 degrees because angles in a semicircle is right angle. Then for PRQ, 180 minus 90 minus 74, which is 16 degrees. The reason for that is sum of angles in a triangle equal to 180 degrees. In this question says 100 students solve the puzzle. The table shows information about the time taken by each student to solve the puzzle. Work out an estimate of the mean. So for the estimate of the mean, we need the midpoint of the intervals first. So midpoint of 20 and 40 is 30, 40 and 60 is 50, and 60 and 100 is 80. So for the mean, you find the sum of the product of frequency and the x values, the midpoint, and then divide by the sum of frequency. So that's going to be 30 times 30 plus 50 times 40 plus 30 times 80 divided by the sum of frequency, which is 100. That's going to be 900 plus 2000 plus 2400 divided by 100. That's going to be 5300 over 100, which equals to 53. That's the estimate of the mean. So main point is to find the midpoint of the intervals and then multiply those values with the corresponding frequencies, add the result, and divide by the total frequency. Then says complete the histogram to show the information in the table. So for the histogram, we need the frequency density. Frequency density is frequency over class width. So let's use that formula to find the frequency density values for each interval first. So frequency density would be 30 divided by 20. Class width is the difference between your maximum and minimum value of the range. So that's 1.5. Then 40 over 20, that's 2. And lastly, 30 over 40, which is 0.75. Now let's use these to make our histogram. So I've already made the bar for the first one. So for the second one, 40 to 60 is this. And then 0.75, which is from 60 to 100. So 1, 2, 3, 4, 5, 6, 7. This is your histogram. 80 adults solve the same puzzle as the students. The cumulative frequency table shows information about the time taken by each adult to solve the puzzle. So we have the time and we have the cumulative frequency. On the grid, draw a cumulative frequency diagram. So first 120, that's going to be this one. Then we have 40, 12. This one. Then we have 60, 36. That one. Then 80, 60. That one. 174. that one. Yep. And lastly, 120, so that's this one. So now we connect the points. Drawing a really ugly graph, but let me fix this. Okay, that is a cumulative frequency graph. Use a cumulative frequency diagram to find an estimate for the median and the lower quartile. So for the median, what we'll do is we'll divide 80 by 2 and find the 40th value. So for the 40th value, we will draw a line from the y-axis towards the graph, and that gives us 62. 62 is the median value. And then for the lower quartile, we find quarter of 80, which is 20. So we draw a line from 20 towards the graph, and that gives us a value of 48. So 48 is your lower quartile. Obviously, they'll give you a range of values for this because everyone's graph is going to be slightly different. As long as your answer is in the range of values, you will get the mark. Then it says write 0.25 recurring as a fraction. So for recurring decimals, there are a few steps that you need to follow. First step is assume that x equals to 0.25 recurring. 5 is the number that has the dot on the top, which means that is the number that's being repeated, not 2. So 0.25 recurring means that 5 is being repeated. Then we multiply x with 10. So 10x equals to 2.5 recurring now. When you multiply x with 10, the decimal moves one place to the right-hand side. Now again, I'm going to multiply x with 100, which will give us 25.5 recurring now. The reason why I'm multiplying x with 10 and 100 is because I'm trying to create a version of this number where there's same numbers after decimal. If you notice, we have just 5 after decimal and same over here. Once we have the same numbers after decimal, if we subtract the two numbers, the decimal will be gone because there is nothing different after decimal. So after subtraction, it becomes a whole number. And to make the decimal into fraction, we do need whole numbers. So next step is to subtract 10x from 100x. And over here, it's going to be 25.5 recurring minus 2.5 recurring. So 100x minus 10x is 90x. 25.5 recurring minus 2.5 recurring is 23. X equals to 23 over 90. And that is your fraction. Since we can't simplify it, so it remains as it is. So remember, the main goal behind multiplying x with 10, 100, or 1000, depending on what we need to do, is to make sure that the numbers after decimal are same. And once those numbers are same, you can subtract the variables and get rid of the decimal. And this way you will have whole numbers on both sides of the equal to sign. And you just make x the subject and create a fraction on the other side. Then it says that the diagram shows the graph of y equals to 2 over x minus 1. Write down the coordinates of the point where the graph crosses the x-axis. So on the x-axis, it's crossing over here. And that's at 2, 0. 0. So that's your answer for that. Then it says, write down the equation of each asymptote. Now, asymptote is that point where your graph is not passing through. So I'll show you what that is. So if you notice, your graph is not touching the y-axis over here. If it's not touching it, like if it's not crossing it, that means it doesn't exist over here. And because of that, that point becomes your asymptote. So in this case, your y-axis is clearly your asymptote. And over here, if you notice, your graph is also lying above and below this line. It's not, it's not crossing it, because if it's crossing it, this graph would cross the x-axis over here. And over here, it's not going below, it's just staying above of it, which means y equals to -1 is also your asymptote. You have two asymptotes, the y-axis and y equals to -1. So in your answer, you'll write x equals to 0 because the y-axis is x equals to 0 and y equals to -1. These are the 2 points from where your graph does not pass through. By drawing a suitable straight line on the grid, solve 2 over x minus 1 equals to 0. So originally the equation is 2 over x minus 1. There's a negative x that's extra, which means if we move that to the other side, 2 over x minus 1 equals to x, we need to draw the y equals to x line. So we draw the y equals to x line. We just this is your y equals to x line. And they want to find the intersection points. X equals to -2 and x equals to 1. These are the two x values for the intersection between y equals to x and these two curves. So just write -2 and 1. It's very important you compare your new equation with the old one and see what has been added to it. Like, what's the new thing? And then you have to isolate that new thing to the other side, so that on one side it's the original equation and on the other side it's the other stuff. So that other stuff basically gives you an equation of the straight line, and then you have to draw that straight line on the grid and find the coordinates for the intersection between the straight line and the given curve. Then it says the diagram shows a solid made by joining a hemisphere to a cylinder. The radius of both the hemisphere and cylinder is 6 centimeters. The height of the cylinder is 5 centimeters. Find the total surface area of the solid. Give your answer in terms of pi. So for the total surface area of the solid, we need the area of the hemisphere and we need the curved surface area of the cylinder along with the base area. So for the hemisphere, we divide 4 pi r square by 2. Because 4 pi r square is for the surface area of a sphere. For half of it is going to be 2 pi r square now. So 2 pi times 6 square, 36 times 2, that's going to be 72 pi. Then for the cylinder, it's going to be pi r square because we have one base area now, plus 2 pi r each. 2 pi r is the curved surface area. So pi times 6 squared plus 2 pi times 6 times 5. That's 36 pi plus 60 pi, which is 96 pi. Now for the total surface area, we'll add the two. Total surface area is 96 pi plus 72 pi, which is 168 pi. And that is in terms of pi as asked in the question. So remember, for the cylinder, we only have the base area, so the circular area is exposed. The top circular face is closed with the hemisphere circular base. So that's not outside, so it's not a part of the surface area. Surface area is the surface that you can see. So it's this top hemisphere, and then the curved part of the cylinder and the base of the cylinder. Find the value of 125 to the power of 2 over 3. Whenever we have a fractional power, what you need to do is you need to change your base. So 125 is the same as 5 cubed. So rewrite this as 5 cubed now, and the power outside remains the same. So if you remember, one of the rules of indices is that when there's a power inside the bracket and outside the bracket, we multiply them. So 5 to the power of 3 times 2 over 3. The 3's get cancelled out. That's 5 square, which is 25. So main thing is to convert the number into a prime factor base. They will never give you a number that cannot be converted, and you need to know the basic cube numbers and square numbers, so you're easily able to identify that, oh, this can be rewritten as this. So that's very important. Then 4 to the power of negative 5 over 2. Now we have a fractional and a negative power. It's not just a fraction. So to make a power positive, we take the reciprocal of the base. So 4 will become 1 over 4, and the power goes with 4, but now it's positive. You don't flip the power, you change the sign of the power. But you will flip the base. So 4 becomes 1 over 4, and the power becomes positive 5 over 2 now. So once again, rewrite 4 as 2 square. So 2 square whole power 5 over 2. Multiply the power. So 2 times 5 over 2. That is 1 over 2 to the power of 5. 2 to the power of 5 is basically 2 being multiplied to itself 5 times. So that's 32. So 1 over 32 is your final answer. Then it says rationalize the denominator, giving out the simplest form. So when you're rationalizing a denominator, what you do is you multiply and divide the fraction by the surd. So surd is root 3, which is in the denominator. So you multiply and divide the fraction by that. 9 times root 3 is 9 root 3. Root 3 times root 3 is root 3 squared. So whenever you're squaring a surd, the powers get cancelled out and we're just left with the number inside the root. So it becomes 3. And 9 divided by 3 is 3. So the answer is 3 root 3. Now if we compare this with the original one, in the original one, the surd was in the denominator. And now it's in the numerator, which means we rationalized it. The surd was gone from the denominator and now it's in the numerator. Then it says 5 minus root 2 and then 1 plus 3 root 2 are being multiplied. And that equals to c plus k root 2. So it's expanding brackets. The steps are similar to when you're expanding brackets with variables, but since there's surds now, so a few things change. So 5 gets multiplied to 1 plus 3 root 2, and then negative root 2 gets multiplied to 1 plus 3 root 2. That's equal to c plus k root 2. So 5 plus, now we're multiplying a whole number with the surd. The numbers outside the surd will get multiplied. So it becomes 5 times 3, which is 15, and the root comes as it is. Negative root 2 times 1 would be negative root 2. And negative root 2 times 3 root 2 will be negative 3 root 2 square. We're multiplying root 2 with root 2, so it becomes a square number. Equals to c plus k root 2. 15 root 2 and negative root 2 are like terms, which means we can subtract them. So 5 plus 14 root 2 minus 3 times 2. Like we did before, when you square a root, the powers get cancelled out. So it becomes 3 times 2. So 5 minus 6 plus 14 root 2. That's negative 1 plus 14 root 2. This is what equals to c plus k root 2. Now, based on this, our c value is negative 1 and k is 14. So you must have noticed that the expansion was similar to when you're expanding with variables. You need to be careful that now that it's a surd. So if you square a surd, the powers get cancelled out, and only surds can be added or subtracted from each other, given that the number inside the root is the same. If it's not the same, you cannot add or subtract them. Then it says write as a single fraction in its simplest form. So when you're multiplying fractions, it's best to start simplifying it if possible. Simplification can be done vertically or diagonally. So over here, the a divided by a is 1, so that gets cancelled out. 3 becomes a 1, 6 becomes a 2. So that's 5b over 2. Then when we're adding fractions, and if the denominators are not the same, we need to first make the denominators equal. So we have a denominator of 4 and 2. We can easily turn the 2 into 4 by multiplying it by 2. But we'll not just multiply the denominator by 2, we multiply the numerator by 2 as well. It's going to be 2p over 4 plus 3t over 4. Since the denominator is the same, we can add the numerators. So 2p plus 3t over 4. We don't add the denominators, we only add the numerators. Then it says 2 over x minus 2 minus 3 over x plus 1. Same thing, we need to make the denominator same first. So we can multiply the first fraction by x plus 1 and divide it by x plus 1 as well. And for the second fraction, we multiply and divide it by x minus 2. So that's 2x plus 2, I'm expanding the bracket, minus 3x plus 6 over x minus 2 times x plus 1. Negative x plus 8 over x minus 2 times x plus 1 is our final fraction. Then it says y is proportional to 1 over root x. When x equals to 9, y equals to 2. Find the value of y when x is 36. So this is direct inverse proportion. Very simple. They've given you the equation already. So what you need to do is you need to replace the proportionality sign with equal to and then write k over root x. So you always replace the proportionality sign with the constant of proportionality, which is k. So we have x, we have y, so let's replace those in the equation and find the value of k first. So 2 equals to k over root of 9. 2 equals to k over 3. 2 times 3 is k, and that is 6. So y equals to 6 over root x. We have to find the value of y when x is 36. So 6 over root 36, which is equal to 1. So y is 1. And this value of 1 will be positive and negative because we're square rooting it over here. So positive, negative over here. Then it says when x is increased by a factor of 4, the value of y changes by a factor of b. Find the value of b. So y equals to 6 over root x. That is your initial equation. They're saying that x is increased by a factor of 4, which means it becomes y equals to 6 over root of 4x, and y becomes b because y changes by a factor of b. So when we take this square root of 4, that gives us 2, and this becomes root x. So if we isolate this, 1 over 2 bracket 6 over root x. 6 over root x is the same as y, and p is the same as 1 over 2, which means 1 over 2 equals to p. That is your answer. When it says the diagram shows the graph of y equals to 3x minus x cubed. The graph crosses the x-axis at A, at O, and at P. The turning points of the graph are at P and Q. Find the x-coordinate of A and the x-coordinate of B. Give your answers as exact values. So for the x-coordinate of A and B, we need to put y equals to 0 because they're the x-intercepts. So 0 equals to 3x minus x cubed. X is common, so x bracket 3 minus x squared. One value of x is 0. Then 3 minus x squared equals to 0. 3 equals to x squared, and root of 3 is x. So A is going to be negative root 3 and B is going to be positive root 3 and the third intercept, which is the origin. Differentiate 3x minus x cubed. So for differentiation, what you do is you bring the power down of the variable, make it the coefficient, and then subtract 1 from the power. So x has a power of 1, 1 comes down, so 1 times 3, and x to the power of 1 minus 1. Now again, 3 comes down, and 3 minus 1 in the power. So that's 3 minus 3x squared. 3 times 1 is 3. 1 minus 1 is 0. Anything to the power of 0 is 1, so x becomes 1. And this becomes 3x squared. Then find the coordinates of P and Q. So that's the turning point. For the turning point, we always put our derivative equal to 0. So 0 equals to 3 minus 3x squared. 3 equals to 3x squared. 3 divided by 3 is x squared, that's 1. Square root both sides. So x equals to plus minus 1. Now if we go back to the graph, P is -1 and Q is +1. So we have to now find the y values because it says coordinates. So equation was y equals to 3x minus x cubed. For P, the x coordinate is -1. For Q, the x coordinate is 1. So to find the y values, you put x equals to -1 and 1 in the equation of the curve. So at x equals to -1, y equals to 3 times -1 minus 1 cube. That's -3 plus 1, and that's -2. So this is -2. And at x equals to 1, y equals to 3 times 1 minus 1 cube, which is 3 minus 1, and that's +2. So that's Q. So for the x-intercepts, remember, you always put y equals to 0. Then for the turning points, you put the derivative equal to 0, find the value of x. And then for the y value of that x point, you put the x values back into the original curve, and that gives you the corresponding y value of that point. Then write down the exact value of tan 60. Tan 60 is going to be √3. How do we know that? You need to know special triangles. So 90, 60, 30. If the length opposite to 30 is 1, the one opposite to 90 would be 2. And the one opposite to 60 would be √3. So for tan 60, it's going to be opposite over adjacent. So √3 over 1, that's √3. That's your answer. Then solve 2 sin x minus 1 equals to 0, where x is greater than equal to 0 but less than equal to 360. So 2 sin x minus 1 equals to 0. 2 sin x equals to 1. Sin x equals to 1 over 2. So if sin x equals to 1 over 2, that means 30 is the angle, because then this becomes the opposite and this is our hypotenuse. So sin 30 is equal to 1 over 2, which means x can be 30 or x can be 150. Why 150? Because sine is positive in the first quadrant and the second quadrant. Angle is measured from the 0 axis. So this and then this. So 180 minus 30, which is 150. That is the other angle, where sine has a value of 1 over 2. In this question, says on diagram OA is parallel to BC. BC is thrice of OA. So BC is going to be 3 times A. M is the midpoint of AC. The position vector of A is A and the position vector of B is B. Find the position vector of M. That's basically this thing. So first we can begin with finding AC. That's going to be AO plus OB plus BC. AO is going to be -A because you've changed the direction. OB is B and BC is 3A. So 3A minus A is 2A plus B. Now M is the midpoint of AC. So AM is going to be 2A plus B divided by 2. To find OM, we can use AM because AM is going to be AO plus OM. So 2A plus B over 2 equals to negative A plus OM. Take that to the other side. 2A plus B over 2 plus A. And that's going to give us 4A plus B over 2. That's the position vector of M. So it's a very step-by-step thing. It says OA is parallel to BC. BC is thrice of OA. So first we find BC. M is the midpoint of AC. So after that, we're going to find AC. Because without AC, we cannot find the midpoint, which is M. So once we have AC, half of that is AM. Then using AM, we find the position vector of M. Because A to O to M is AM. So OM becomes OA plus AM. Then the line y equals to 7x plus 3 intersects the curve y equals to x squared plus 5x minus 12 at the points A and B. Find the coordinates of A and B. So if they're intersecting, that means they have a common point which we're trying to find. So we can put the equations equal to each other. 7x plus 3 equals to x squared plus 5x minus 12. When we say that they're intersecting, that means there is one x and y value that's common. So we assume that this y and this y is the same for that point. So 7x plus 3 is equal to x squared plus 5x minus 12. Collect all of the terms on one side. X squared plus 5x minus 7x minus 12 minus 3. X squared minus 2x minus 15. Now we have to factorize this quadratic equation. You can use splitting the middle term or the quadratic formula. If you use splitting the middle term, you have to find factors of 15, which are 5 and 3, along with 15 and 1. But we're going to use 5 and 3 because 5 minus 3 gives us 2. So we're going to replace the middle term with the factors of 15. So it becomes negative 5x plus 3x minus 15. As you can see, everything else is the same. The only thing that's different is the middle term. The middle term is replaced by this. So now we factor by grouping. The first two terms make one group. The last two terms make another group. In the first group, we have x common. So x minus 5 comes in the bracket. In the last group, we have 3 common. So again, x minus 5 comes in the bracket. Between x and 3x minus 5 is common. So x plus 3 come in the second bracket. X equals to 5. X equals to negative 3. They want the coordinates. Now we have to find the corresponding y values. For this, I'm going to use the linear equation because that makes the calculation easier and less time consuming. So at x equals to 5, y equals to 7 times 5 plus 3. That's 35 plus 3 and that's 38. Then at x equals to negative 3, y equals to 7 times negative 3 plus 3. Negative 21 plus 3, and that's going to be negative 18. So one coordinate is 5, 38, and the other is negative 3 and negative 18. That's your answer. And with that, we're done with the question for the second variant for paper 2 extended maths. If you have any questions or confusions, please leave a comment below and I'll help you out. If you understood everything, please like and subscribe and share this video with your friends.